Thank you guys for being on time today. I really, really appreciate it. And that was a really exciting chat. I enjoyed it. And today we're building on the session we did last week on ecology. And we want to talk more in depth about the process of ecological succession. And so I know we talk about accelerated succession in the garden and successional agroforestry and all of these things, but succession itself is a process through which nature builds. And so I know some people are really familiar with succession, and we want to give those people the opportunity to share their knowledge and to practice their teaching skills and their ability to communicate information in a really clear way so that other people who aren't familiar with ecological succession can all learn together. So we're going to break up into groups. And for just as a broad definition, I would say ecological succession is the process through which nature builds after a disturbance, be it a fire, a flood, land clearing, an earthquake. How else would you? What are other disturbances?
Yeah, to be honest, human disturbances.
Yep. Yep.
Like even the time going out.
Yep. Yeah, like so. Moving from that bare earth or bare soil into a forest, like a stable, complex forest system, and that you don't just get a forest. And so nature actually builds, and through understanding how that process happens and why that process happens, will help us to grow food better in line with nature's process, natural systems, and succession. So, can I get?
Can I just say maybe more another way to look at it, maybe more broadly speaking, ecological succession could just be how ecologies change over time as well. It's not necessarily going towards a forest or just to put in a broader context. I think that might be one. But in terms of our local context, the forest is a part of that process.
Yeah, I like that. Think wider than the forest. Wider. Who is familiar with the idea of ecological succession? Cool. I'm going to give the four of you, a little pack, and if you can number off 1, 2, 3, 4, 1, 2, 3, 4. The task is basically in groups to put together the story of ecological succession. So you've got some tools. You don't have to use them if you want to make your own. We've got spare paper. And we've got a few key things to consider during your process are, we talk about what's happening above and below the soil, animals, role of animals.
Yep.
What's happening? Okay, I'm going to write it down. I will write it up. Above and below the soil, the role of animals, and number of species.
Yeah,
really.
And I'd say, I think to give some more definition to this task, we'll talk about ecological succession, like on our farm, the context where some of you guys have, all of you guys have got a connection to, and some of you have got longer than others, to understand some of those, the key players in that thing, that might be plants, animals, that might be soil ecology. What are the key players that we have on our farm here that we're working on together? And I would say the context for setting up this task, because there's many different ways it could be going, would be to look at a given disturbance on that farm. So I don't know if we need to define that disturbance, but I think the disturbance is back to bare soil. I think it's probably where we're starting. So some sort of disturbance that's created bare soil, and how that process might evolve with some of the key players on this property here in this ecology.
Cool.
So what are we supposed to do with this?
You're going to join your number 3. Yeah. You're going to meet up with Kenji, and as a group you guys are going to discuss and learn about the process of ecological succession.
We should put them all out?
Yeah. Let's have a look at them all. So we got small trees, softwoods, perennial grasses and shrubs, pioneer species, nitrogen fixers, lichen, mosses, fungi, bare rock, bare soil or rock, grasses, annuals, weeds, hardwood, trees, forest systems, climax keys.
No, that could go last. Let's go first, second.
Yeah.
There's soil.
We talk
Where's
about like
weeds?
what might happen next.
So I guess like biology is in there. Seeds might be dropped by birds or passing animals. Water, irrigation, water flows and stuff like that. So if there's humidity, lichens and mosses, fungi, kind of grows. And then I'd say it's this one. Then you get grasses, annuals and weeds. Oh wait, pioneer species and nitrogen fixers.
I think these are good ones to debate around.
Yeah.
Yeah,
Like
this is pretty clear.
starting with vessel. I also think it's kind of different starting with vessel or rock. Like they're both quite different.
Yeah.
Like if you were starting with just rock, like for me, the only thing that can turn that into soil is fungi. But yeah, I guess it'd be different if it was soil because
Yeah.
you could get grasses coming in before fungi really dominate.
Mm-hmm.
Because like, I don't know, what do you guys know about fungi and like what they do under the soil and stuff?
No, you.
Yeah, I was gonna say it breaks things down,
Yeah.
deteriorates into the next form. So you saying that you said I kind of have I can see their soil being easier to be broken down and turned into stuff than rock. How did you said fungi is rock?
Yeah. So like my understanding of fungi is that basically they are the only thing in the world that can actually turn rock into soil. And they do that by sort of like digesting the rock, like they create that soil basically with fungi, and then all the other things evolve because fungi.
So
Yeah, it's always like fungi comes first. But yeah, if we're talking in context of like say in the market garden, the big floods that happened like a month ago, got washed away and it was left with bare soil. Like what would come next in that context?
No, I thought the way that they were doing this maybe was like rocks and soil, and that lichen and mosses tend to grow on rocks, and fungi more in the soil with the mycorrhizae and everything.
Yeah.
So 1 and 2, their soil and then fungi.
Pioneer species makes me think of like first
Yeah, they're the
species
first
that
one to
come
come up.
Yeah.
Any other challenges?
I don't know. Yeah, I'm really confused between the two because also like if you get nitrogen fixers, it feels like you need them anyway to precede more like green matter or green stuff growing.
Like I think these are up for debate. I can view nitrogen fixers as the ones that come in and make the soil more healthy.
Yeah.
And then like that creates that removes the limit in the soil. You know, we talked about like limits. What's the word?
Capacities.
There's there's always something that stops forests from happening.
Yeah.
Whether that's like light or nutrient level or whatever. So I view pioneer species as like something that kind of removes that level of nitrogen limit to allow bigger things to come in. But like whereas grasses and weeds and annuals will often like weeds and grasses will just come up.
Yeah,
Like in our garden.
Whatever they're
Yeah,
whatever
they're the
plant
first
will be
thing.
there.
Yeah.
But then I guess annuals makes me think vegetables which need compost.
Yeah.
Yeah.
So could it be perennials instead?
All right.
Because shrubs like to
Bigger, yeah, more over time.
yeah.
Could it go that?
My instinct is saying like grasses tend to just come up first. Like
Yeah.
like and when we disturbed the soil for the nut grass, like it just popped up and created that disturbance. And then
Grasses, and then we're thinking pioneer species, nitrogen fixers.
what do you guys think?
Yeah. Because I think then even more diversity then would come in because the fixing.
Yeah.
So that, and then it's like grasses and shrubs.
Yeah.
It's like
Getting bigger. More.
What would be a pioneer species around here?
Something like the legumes that we put in that shoot up really quickly and like fix nitrogen into the soil.
Okay.
Like the daikon radish is like a
That would be considered a pioneer species.
I think so, yeah. Or like yeah. And
Is that a cassava?
so that would be.
I think that's a legume.
I
Like,
feel like getting
see the little legume leaves.
Oh, yeah.
Stuff like
Some moringa.
moringa is a legume, yeah.
Yeah.
Yeah, that would be considered a pioneer.
Okay.
It's, I view pioneer species as like fast-growing things that create like a good environment for other longer-term things to grow.
I see, yeah.
Like they shoot up and yay, and then they usually get chopped back, and then they just make the soil healthier so that bigger shrubs and trees can grow. Stuff like the cassias and like the iguana tipus and all of those different legume species. And then like you can, it doesn't have to be legumes. It can be other things like ground covers. I would put somewhere in here, like sweet potato and other kind of Japanese Singapore daisy and stuff.
You're kind of thinking of a farming context in this case, no?
Also in a forest, I think, like in an agroforestry system. Yeah.
No.
But yeah, if we're thinking in like wild forests, yeah,
I think it makes sense.
they kind of shoot up and then create a more stable environment for bigger things.
Oh, that's interesting. Cool.
What do you reckon's next?
I think the order is
Yeah.
right.
Yeah, the word is already right. After perennials and grasses and shrubs, we have small trees, softwoods, then hardwood trees, forests, and the climax is reached.
Why do you think Why do you think it would go in that order? Like, why do you think the shrubs would come up before?
Oh, the first small trees. And perennials. Maybe not. These would go shoot up first, and then the shrubs would go on.
I think that this is this is good.
Because I think perennials would shoot up faster than the small trees.
And what about, and Brian, this is for you as well, pioneer species and nitrogen fixers, or perennial grasses and shrubs first?
Well, pioneer implies that it's pioneering, and then nitrogen fixer is going to be helping to create an environment that's going to allow the other perennials to thrive. I think you guys have done really well with the
Exactly
order.
what we just said. Yeah.
I think like is when I'm thinking about the different levels, I always think about what the limiting factor for each level. So like back here, the limiting factor is going to be stuff like the nitrogen levels in the soil, and like the soil structure. Then when you introduce the pioneer species, the limiting factor changes to stuff like light availability and like spacing. So yeah, and that's why I think this order makes sense, because when you get like the shrubs coming up, they're not as limited by up here. The limiting factor would be light and like space, because all these big canopy things might mean that it's harder for things underneath to grow. Whereas here it might be that's not limiting.
Yeah.
So yeah.
I think for the small trees, like trees often need a nursery plant too, so the light requirements is spot on. Like without being sheltered by those small shrubs and perennials, those soft trees don't have a chance of getting established. Or once you get into nitrogen fixers and more grasses as well, in nature there's usually animals involved too, so there's lots of disturbances from ruminants. The shrubs won't get impacted by large animals, which will help facilitate the growth of the smaller trees.
And what's happening under the surface throughout this whole process?
You go.
We were talking about how the fungi is breaking down the rocks and turning that into soil. So that's already starting movement in the soil to make it rise. And mycelium bees spreading out further and further and talking to everything.
Yeah, the biological succession is really interesting from the transition from rock to an old growth forest.
Like fungi.
That's one of my favorite things to imagine is like, like after a volcano explodes and it's literally just volcanic rock, which is where we are. And then this area is all rainforest, like the lichen and mosses to create an environment for grasses. But I don't know. I love thinking about it because it's huge time scales.
Yeah.
Yeah, and like it is right that fungi literally came in and broke up the rock and turned it into soil.
Yeah,
Like,
they were the first ones to make it onto land. Yeah.
And like at one
600
point the
million
earth
years
was
ago.
literally just full of giant fungi, like massive
Oh.
rock, and they turned it all into soil. That's how it all began. It's crazy. They were mushroom trees. Well, yeah, that's what we were kind of talking about at the beginning. So cool.
But then so these guys will have like a really fibrous root system.
Yeah.
And like arguably, I've heard, grasses and annuals and weeds and things, like they're the first, we're like, oh, it's so annoying, the grass, but like it's the first protector of the earth. Like the earth doesn't want to be bare. And yes, this is important, but these guys, like, yeah, and they hold the moisture in, and their roots will start creating space in the soil. And then it's like every stage creates the conditions from which the next stage can then, like you can't put a tree into a rock because it needs all of these other stages
That work
in
well
order to
with
break.
that limiting
Yeah.
factor sort of thing.
We were debating between the pioneer species and the grasses, but what you confirmed was the grasses come first.
Yeah, like especially because a lot of grasses, most grasses, are wind. Their seeds are really light and they'll blow in from the wind. Whereas pioneer species and nitrogen fixed particularly have quite. I don't know if anyone was sowing broad beans in the tree rows, but like they're very big, and not all nitrogen fixes have such big ones, but they don't carry by the wind as much as grasses.
Yeah.
I feel like it's really interesting to think about like succession in this setting, and then also in other different environments on Earth. Yeah, I just think it's really interesting how you can apply like the different levels of succession to like every ecosystem basically, and think about how they all began from there. So cool.
Yeah, it's amazing.
And what I find interesting as well is that not everywhere on Earth wants to be forest. Like everyone's always like, yeah, eventually you want this bit of land to be turning into forest, really. But actually, like big mud flats and like meadowland and plains, is all that is like the highest level of succession in that area as well, which is cool to think about.
Yeah, I remember hearing that Melbourne, it was like a massive plain, and the local indigenous people knew it as like the place where you get emus. You could see them from far away, and they were just like the native grasses in there were just so diverse, and all the different animals.
I guess on that, like, conifer trees and stuff like that being softwood are some of the largest forests we have. So I think it's really cool to point out, like, almost these three are like, can be the pinnacle of succession.
And like, the like perennial grasses. Then also in desert, like it's like the highest level of succession in a desert, and you might not have like any much ground cover at all. So lots of people try and like reforest places that just like don't actually really want to be forests. And I think that's where people miss. Like that's why it's good to have an understanding of succession.
But I always thought it was the natural way, like eventually the forest would gain ground on a meadow or something. It's not.
If in the right conditions, like with the right, like if the certain factors aren't limiting, like climatic or topographic factors, like it depends on the level above sea level and the
species that you like are there, whether they keep it down or whether things continue to grow.
So, like savannas and things like that are natural.
Yeah.
Millions and millions of ruminants running around.
Yeah.
Like, and they might be a mixture of all three of them, but you wouldn't call it an old growth forest.
Yeah. So, like where I'm from, there's a huge field, and then there's the forest, and yeah, like we lived there over 20 years and it never changed. But do you think? Because I'm like, okay, the trees are gonna have their leaves fall, and then it's gonna cover the ground, and as you know, the more the leaves fall, it's gonna cover a bit more and a bit more, and then it's gonna create that organic matter and the humus and everything. And then if the seeds get there, like it should gain ground, but it's not. And do you think that's because the ground is different, the soil maybe there's more rock or something, or
Yeah, lots and lots of variables, whether it's climate or animal disturbance or like, you know, if it's an area that gets, like California consistently doesn't get rain for 4 months of the year, and like for it to be constantly burning is the norm.
yeah,
So like those natural disturbances are going to hold the succession at a certain point.
okay,
So it's not always going to transition into an old growth forest.
okay.
And the humans coming in and doing things like house lots and stuff, that's basically stopping the succession of the land. And just putting it...
And what happened here 100 years ago with Europeans coming and trying to graze cattle and stuff like that and taking down the forest, and the amount of work they put in. One of the properties me and Michaela went to look at, they said that the story of the property was there was one patch of rainforest left that didn't get touched, and the story was that because it had been passed down for generations, like their grandfather had left that patch for their kids to take down to show them how hard it was to remove it. Yeah. And how much work it takes to maintain a pasture for cows. Like, I thought that was really funny.
I think it's harder to take it down than it is to restart in that forest. Yeah, wow. They're like, no, don't take me. Oh.
Yeah, so humans are trying to. Yeah, it takes a lot of energy to stop succession from happening.
It's like constantly battling against nature a lot.
But it can also be slow. Like this area of rainforests come down, and then like the camphor laurels isn't a native. I think it's from India, but the pigeons eat them. So like all the fence lines of all the cow properties, because the pigeons come and land on the fence line and poop out the camphor laurel seeds, and so all the fence lines are just these camphor rows. But then in terms of succession, like they're a pioneer species, and they act as some people call them allelopathic, so some people say that tree is preventing other trees from growing, but you go out and look, there's lots of native trees coming up underneath them. They've got like 100-year lifespan, so they're a pioneer, but once their life is over, they've acted as a nursery tree to propagate a whole bunch of these that are then going to take its place and come up underneath it.
So, yeah. Do you feel like you could apply succession to like lots of different kind of environments, not just old growth forests as well? Or like the concept of it?
Yeah. Definitely. I was just thinking of like the Australian like desert and like driving out there and actually seeing all this life, seeing all these like oases and like understanding like there were these like Kings Canyon. You can see the. Do you guys think about it's called, but it's where there's been like an earthquake. Yeah. So like desert all here, and then you look down, and because of I'm guessing because it's like kind of like a protected area, it would have caught water, and it would have then soil and rocks and all of that. And so you've got these oases.
So it's like a forest.
Proper.
Yeah.
So all these beautiful villages that are just like throughout the desert.
Yeah.
on the other side of the Himalayas is the Gobi Desert, I think, and that's natural for that same reason.
Yeah.
It's creating a barrier. All the rain falls on the
Yeah.
Himalayas, and then it's a desert on the other side.
Yeah. Is it called? Is something called like a rain block or something, or rain barrier or something?
I don't know the exact name, but rain barrier is appropriate.
Oh, yeah.
So is there one of the groups that feels like they'd be happy to come up and start a little visual process that we can keep adding to with each draw? So what we're going to draw, we're going to depict the process over time, starting from those early succession, moving towards later succession on this side of the board.
So we started with bare rock, or bare soil and rock, and we talked about how then the fungi, lichen, and moss come in and digest the rock and turn that into soil. And the first thing that comes up with healthy soil would be the grasses, annuals, and weeds. And then pioneer species and nitrogen fixers. Perennial grasses and shrubs. Small trees, softwoods, and then hardwood trees for the forest system, and then a plant tree.
Did you guys have any further discussions about any of those stages of succession, or again, like any of those key players, animals, trees, plants, soil biology that might have sparked your interest in that process?
Yeah, we were saying it over the succession it becomes more and more complex and diverse because the fungi, lichen, and moss is turning the soil, or the rock actually, into soil. It allows a better environment for seeds to develop. Seeds that will be brought by wind, animals, etc.
Sorry, can everyone hear Julian, or is that Julian
Greta was telling that those grasses have a very fibrous structure, the roots of those grasses, and they allow more carbon to be stored in the soil. I forgot what you said, because they're fibrous, what does that do? Oh, they're like the first kind of protector of the soil.
You can grind it up to lock it together.
Yeah, and so it then allows those pioneer species to establish themselves, and because they shoot up quite quickly, and they're gonna fix the nitrogen, it brings even more nutrients into the soil, and then we get the grasses, perennial grasses, and the shrubs to also cover the ground a bit more and give shade to then the small trees, and it will protect the small trees to then shoot up and create another strata, and as that goes, like, we get more and more a denser root system, and then they die off, they feed the soil biology, so you get more bacteria, more fungi.
We talked a little bit about how, like, at each stage of succession there's some things limiting, like the factors limiting that doesn't allow the old growth forest to just spring up straight away, and the hardwood trees, it's like at first it might be limiting that there's just no soil at all, and then when there's soil, the limiting factor might be like a lack of nutrients or a lack of structure. But then as more species establish and those pioneer species get to establish, those factors become less limiting, and then you might be looking at factors like light and protection from wind that's the limiting stuff. So then maybe the shrubs and grasses are the things that come in. And like at each stage, just different things provide the environment for the next level, and it has to happen before you can reach that final level, rather than it being like straight to the
Yeah, I think that's an awesome point. Did everyone hear that? You need the previous stage of succession to create the conditions for the next one to grow. And I really love that idea.
That's great. That was implicit in what you guys were sharing all along. It was good to solidify that at the end, because I think that was inherent in what you guys were sharing about your process, that you were observing that each of those changes creates a new opportunity. And interestingly, whilst this is an amazing epic collage that goes on of these processes happening, as a general movement in an area over time after a disturbance, as you guys mentioned, generally diversity does increase over that time. Short of further disturbances or other limiting factors that might come into play with that. That's a general trend that we see in ecological succession. And along the lines with one thing preparing the opportunity for another, the opportunity it prepares for is generally for another, not for itself, we tend to see. It actually prepares an opportunity for another whole community to usually move in. And the particular task or role that community or that group of organisms, that guild, plays, it then needs to play out somewhere else if this process is going to continue. That's sort of an interesting part of the system too. It's sort of, we can look at our smaller system within here, but actually it's part of a much larger system, that some of those players might be here for a while and then they're next door, or then they're across the range, or then that seed's blown somewhere else. So you guys mentioned, or someone mentioned through seed coming in by birds or animals or wind or something like that. So for this system to progress and move forward, there needs to be movement of those organisms to other areas. So they sort of do a task, the task is fulfilled, something's been prepared for the next stage of succession. Those organisms then need to find their way to where their next task is in a way. And this actually reminded me, I don't know if anyone's come across this book, which I've been reading I just started again after a few weeks of moving, I couldn't touch a book. Yeah. So there was actually something right at the start of this book that was really relevant to this, and I brought this in as a visual prompt for myself. This is called Sand Talk, written by amazing Indigenous guy, Tyson Porter. And what he mentions right at the start of this book, which is embodied knowledge of one of the oldest continual cultures on Earth, and it was like, which alludes to this change. The change over time is inevitable, and it was like societies that don't move on get moved on. That's his view of history through his cultural lens. It was like that cultures that don't accept, and it's not necessarily even move on as a like, we're going to move our house from here to here, but if we don't accept change within our land use, change within our patterns of the landscape, we're actually fighting this process. And so, I'm sure you'll find that's the embodied knowledge of most long-term Indigenous cultures, is understanding the change. And this succession is a way that, again, we talked before about James Lovelock and the Gaia hypothesis, and some of these changes that happen in science in the 70s has sort of opened its perception to that. And I think as we take that on to understand this process, it implicitly changes the way we look at the way we work with our land use. So yeah, change is the constant in this process, is change. Did any other group want to add some more richness to that, or some discussions they had, some insights they had, thoughts, questions?
An interesting point that we kind of talked about was like how the perennial grassland, softwoods, and old growth forests, in some situations, due to the environment or other limiting factors, could be like the pinnacle of succession.
Yeah,
or the climax of succession.
That's right. So limiting factors could be things like rainfall, soil fertility, or natural disturbances, wildfires, all sorts of things that aren't necessarily imposed through human activities or intentional land management. It could be extreme lengths of winter. It could be extreme changes in daylight levels that happen at different latitudes. So absolutely. So that was why kind of from the start we talked about that whilst for us here forest ecology is a key part of this scenario, in many environments it's just not. Forests are just not a part of that story. Not in our human time frames, maybe in a broad geological time frame, they eventually have their place. So there's a lot of evidence showing that places like the Arctic and Antarctica have had huge rainforests. on them. So on some cycle, this change seems to be there, but in our general reality and time frame, in a lot of areas, ecological succession look very different. In desert areas, in Arctic areas, in areas with different limiting factors that led by forests. So for instance, in the Australian landscape, from my time in southern tablelands and highlands Australia, we have the tree line is actually 1,800 metres. So prior to the introduction of trees from the northern hemisphere, from Europe and North America, and where trees have adapted to a lot more intense cold, prior to that, there were no trees above 1,800 metres in Australia, above that altitude. Trees weren't surviving. Eucalypts, acacias, the trees that were surviving in areas below that latitude in the mountains were not able to survive through those winters in snow. We now see things like pines from North America self-seeding and growing in areas where native trees were never growing. So above that limiting factor to succession there was actually altitude and the extremes of cold that come with that, and the ability of the genetics of Australian trees to actually cope with that extreme.
I was watching something last night on using drones to plant trees.
Yeah.
It had something to do with the social media goal to plant 20 million trees. I don't know if anybody saw that was a few of them, but they're going out and looking at a lot of these native forests and after the forest fires, they're no longer regrowing the trees. What's happening is all that's coming in is shrubs, and trees aren't coming back, so they're not getting back. The fire comes through, rips out a bunch of old growth trees, and no trees come back. So they're using drones to go in and drop tree seeds, and within days of the fire, when people can't even go in while the soil is ready to take it, because otherwise they're not even seeing that last stage come back in. So
yes, this is right. So sometimes now
changes and different things that are happening that are changing the overall conditions aren't allowing them to go back to what they originally were.
Yeah, so that could be that some of those factors could be human-induced climate change and partly natural climate change and like that. Some of those factors could be human management of having fire too regularly or too infrequently can really damage this process. So a lot of these ecologies have been built up over long periods of time of ecological and cultural time frames and factors that have created unique genetic niches and niches in time and space, which if humans then come in, as a lot of the colonial culture has done throughout the world, and just dominated a different idea from a different place without that nuanced understanding, we can actually be having huge impediment in this process. So that's cool that there's technological responses to that and human responses to try and deal with that issue.
Does anyone else have anything to add? Yeah.
Just one little thing on tree planting. I feel like this is so relevant for people's understanding that go into tree planting endeavours, because like I know in the UK, I don't know if it's the same here, but a lot of the tree planting projects that get done, they're just putting in saplings like hardwood trees on like bare agricultural land, and there's not an understanding that like without the level of like diversity in the soil and the fungi and stuff, it's going to be really hard for those trees to establish. And yeah, I just feel like it's so relevant to learn this stuff and to spread the word about it, so that I don't know what the solution
That
is.
just happened here.
Yeah.
Last year in the middle of the drought, as dry as it was, our neighbor got funded by Australia to plant a whole bunch of trees. None of them were going to possibly survive. Didn't have any water from them. Came over here asking us for 1,000 liters of water, which we gave them, but wasn't going to do anything for it. But that was all government funded tree planting.
But in a very good development on that, I've contacted them. It's a group called Reforest Now, who are trying to take the lead in re-establishing the native rainforest that was here, which is called the Big Scrub, and I think only 1% of that Big Scrub is left. And I asked if we could try and have an education day, because I would love to be able to talk to them about not growing forests in a grass paddock, but also to have like that opportunity to do more revegetation here. So that is coming.
Cool.
It's really cool.
Yeah.
I feel like we can, two birds, one stone. Like, hey, that's not sustainable. Weed mat in the middle of.
That's right. So a good bush regener will understand this process well.
Yeah.
And there's some that work a bit more on, as some farmers do, work a bit more on a kind of management template of kind of spray that, knock that down, plug it in at that input. Or you can say, where is the stage of succession at? How can I just kind of support that process to move through? So again, there's sort of more institutional approaches to bush regen, which are a bit more cut and paste. And then there's ways of bush regen that can sort of really integrate this process well. I know some regeners that have taught me a lot about this process that work with it really well. So one of the things that you guys also talked about, I want to look at the trends over time that happen here, because there's lots of different details that can happen, which is what we learn more and more as we go. So working from the patterns to the details in our Fermi principles. One of the patterns that came up when you talked about planting a tree is not necessarily ready, the soil biology is not quite up in there. We tend to find soil biology shifting from a more bacterial dominant soil in those early stages, and as carbon builds in the soil, particularly as woody carbon and large carbon builds in the soil, to a greater fungal activity and a greater diversity of fungal activity as well as that process develops, we tend to find. Yeah.
And it will move from more of a tertiary type of fungi to primary type of fungi as you get into more hardwoods.
Okay, cool. So do you want to explain a little bit briefly about that, tertiary and primary, is it?
Yeah.
Yeah.
Primary decomposers are things like reishi, lion's mane, shiitake, turkey tail. They break down the hard woody material in hardwood trees, whereas then secondary decomposers will start to take over, and they're more coprophilic, so they like partially digested or broken down material like cow manure. And then tertiary decomposers you see a lot in compost piles.
Oh, I've gone the wrong way around, haven't I?
No,
Is
you're
that
right.
right?
So tertiary, if you're thinking like primary, secondary, tertiary, these guys are breaking down like bacteria and already decomposed matter, whereas these guys are breaking down directly the hardwood trees.
Yeah, and it kind of works in succession. So after the primary decomposers are sort of finishing up their job, secondary decomposers will continue on to break down a bit further, and then tertiary until it's fully evaporated.
So would you still get the secondary and tertiary decomposers at the later stages, but you wouldn't have the primary at the earliest?
I think you might. You probably have more primary in the later stages, more fungal dominant, and then you'd have more tertiary at the beginning. And one thing that's really cool about lichen is a symbiotic relationship with bacteria. So it feeds off the bacteria, and bacteria feeds off the fungi for it to grow in those early stages.
Cool. So something that we can see there too from the outset, you're already in this early stage of succession. You're alluding to this cooperation happening. Yeah. We generally see cooperation increasing as things develop. More and more niche opportunities develop, more and more kind of arrangements and opportunities evolve over time. So we generally tend to find that in the early stage, the winners, the successful organisms, the ones that can start this process, tend to be quite vigorous and often tend to be quite competitive in terms of their ability to access resources. And so there tends to be a lack of diversity of more generalist and competitive kind of organisms is what we generally tend to find. So generalist, competitive organisms, and we generally tend to move in terms of the relationships formed between organisms to often more cooperative and specific. If I've got a better word than that, specialist niches tend to evolve as well over time. And something around the diversity which I wanted to bring up, which is really interesting. If we look at over time this diversity if this diversity is increasing over time, we can actually observe a lot of ecologists have observed in some ecosystems that over time, without disturbance, we actually even start to have a decline at a certain point. That disturbance is integral to this system, and this is where human activities, farming, the role of animals are often disturbing. They're scratching, they're creating niches, they might be knocking trees down, they might be ripping branches down. I have a rant on bats sometimes. I've been loving watching bats and what they do to the forest system because I've got to observe them more. But we tend to find as this process goes, it doesn't just keep on going on forever. It's like, because we get to a point later in succession as forests develop, if we don't have clearings, if we don't have disturbance, if we don't have bits opening up for more light, then we actually lose this whole stage of the ecosystem. So whilst our particular land, if our whole land starts to regenerate towards forest and we're here in a few hundred years' time, we never cut down a tree, we never stop that process, on this particular land, we could actually get to a point where diversity decreases, even though the trees on this land might be moving to other lands. So within a larger landscape, we can have diversity of all of these parts of succession, but within a small area, if we actually want to maximise diversity, then disturbance is actually a valuable part of that system. And that's what we do as land managers and farmers, whether it's by working with cattle, with chickens, whether it's working with a plough, whether it's working with a machete or a chainsaw. We're creating disturbances and opportunities which actually help to cycle organic matter, cycle biomass, and open up niches where some of these earlier stages of succession can find a place within this evolving ecosystem. So I think as we develop this more, we'll talk more about disturbance. Disturbance is a key part of that, how we use that intelligently and well in this system. So, yeah. Any other trends that people see as this process develops? So we get stratification tends to increase as well in our system anyway, in a forest system. So the amount of the competition between plants and the evolution of later succession plants, which naturally genetically disposed to grow taller and live longer, generally means that the stratification increases over time as well, which is part of this cooperative specialist niche forming as well. Creates, as that opens up, it creates more microclimates, it creates more differences of light, more differences of humidity, and a whole bunch of factors that change that create more stratification.
Does everyone understand what we mean when we say stratification? No.
Okay, so to begin with here, earlier stage of succession here, we've got on some bare rock, we've got some lichen and fungi. Oh, this is where I need iron. Such a good drawer. And mosses. So we've got it, and they're all kind of very low, and they're not necessarily stacking upon each other so much. There'll be a small degree of stratification going on there. As we move into grasses and a few different heights of annual weeds, we get more stratification. As we move into forest systems, we tend to have really tall trees. Like in this region here, you'll see, you look out on the horizon, you see hoop pines coming through. They're a classic what we call emergent species. They just keep going upwards, 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 and they push through. So the conifers are commonly that. A lot of the palm species do that. They only grow one direction, is up. They don't branch, they don't spread out, they just keep going upwards. We can then have what we might call a canopy or a high strata. We then tend to find plants that actually will only grow happily and successfully underneath some of these canopy species, which we can simplify to call them a mid-strata. And then we have some species that just grow on the ground. So it might be ferns, it might be some of the decomposers, some of the ginger family plants in the tropical forests, a whole bunch of species that will grow just on the ground. They won't be the grasses and they won't be the same plants from out here. We'll have a whole different range of plants that will grow low on the ground here amongst the decomposing biomass and so on there. So then we can call this, so to really simplify, we can have like an emergent strata, a high strata, a mid strata, and a low strata. But there's a whole bunch of things in between. We've got things like vines that start to find their way in. So as light becomes a limiting factor in the forest, we tend to find more creative ways of plants stratifying themselves, of finding their way to get the light levels they're after. Some of them lean on one another and climb up to get towards the top. Some like the strangler fig will actually germinate in the top of a tree, in a trunk from a tree, from a bit of bird shit with their little pellet. It wasn't a drone, that was a bird that dropped that one straight onto a little fork in the plant, and then it sends roots down to the ground. And its creative way of getting to the top is not starting at the bottom and finding its way up. It's starting at the top and sending its roots down, and then eventually it becomes an emergent plant coming out the top. So we get this whole range of strategies where plants will stratify themselves. And so in doing so, we get greater possibilities to increase the photosynthesis, which is what's actually driving a lot of this increase in diversity and stratification and the increase in productivity and biomass that comes from these systems. is by maximising photosynthesis, by having more solar panels stacked up. They're all working more together as one system.
I think, yeah. Great. I would say, yeah, if that's still confusing, the word strata or stratification, I just think of layers. Just think of different layers as just a really easy way to understand it. Okay, one thing I wanted to add, I don't know, does anyone else have anything else to add to this? I feel like something that also happens as we move along this scale is that resilience also increases. And just thinking about it as I was sitting here, I haven't seen, every time I see this graph, the amount to which it drops down over here, it increases. Like the next person is going to be like back down. I don't know why it always just keeps going down over here. But I really agree with what you're saying, that if you go too far this way, without that disturbance to bring it back, and then you don't have this stuff here to kickstart that successional growth, like you're not. What did you write here? Diversity. I don't know, what was it? What was this word?
Yeah, that was diversity. That was diversity over time. Evolving.
And I feel like that's the same with resilience.
Yeah.
If you are here and you've still got these early stages of succession somewhere in your system, you're more resilient to a disturbance because you can rebuild really quickly. But once you go too far that way, and like that's stable. Imagine like a really big old forest, like it's stable, but if something was to come through and wipe it out and it didn't have these early bacterial stages somewhere there, it would take a long time to regrow.
It's actually interesting listening to Glenn speaking last week, which I learned a lot from hearing his experience in this land over his lifetime. He's been born and bred in this area and watched the landscape change. He was talking about what we see on our hills a lot at the moment is this sort of band of succession happening a lot. We've got a lot of these pioneer species, camphor laurels and some of the acacias, some other species that are sort of the first trees. We've had a very degraded, a long period where succession has been held back to grasses, where trees have been not allowed to grow, poisoned, removed, and by intensive grazing, not given a chance to move beyond this stage. And he's noted through his work that he's seen that just grasslands alone and just this stage of trees which we're seeing here, he's seen that both of those have their challenges in terms of stability of the land. And he was noticing that he saw just as much challenges with this stage of succession of land slipping, of siltation of dams. He was saying more so than he sees in grasses because the grasses have got that tight-knit cover. And what he was suggesting is that if we have a combination of those two together, that forms much greater stability. And in terms of where we're at in our process on this land, I reflected back to the week before. We talked about all the different things we're doing on this property, and we're doing market gardening, we're doing agroforestry, we're doing animal systems. The big one that was like what we're not doing was silver pasture. And in a way, what he was alluding to was that like that's actually possibly one of the better things we could do in our upper catchment is have a better integration of grass and trees rather than trees here, grass there. Is that somehow that was what came up for me when he spoke. Was that silver pasture could be one of those opportunities that we could use to use this stage of succession that we're in a lot of the land, and that is slowly moving this way. But rather than having this strongly defined areas, that somehow there's a balance between those that could actually be coming into the property. Yeah.
In that thought, and along with what you're saying, Brett, this is all talking about succession, and one thing that came up in the group over there was talking about, someone said, well, how long can we keep regenerating the cycle? Was one of the questions that came up.
Yeah.
You know, with market garden, for example, market garden, how long can we keep it up? Well, however long we keep adding inputs back to it, right?
Yeah.
So we take inputs from other parts of the farm, we take the grasses we cut, take the cow manure we get, we take our food scraps, we take things from the ocean, we combine all this, we keep that area regenerate, so we can keep using them again and again, intensively, right?
Yep.
And then we go in, so like looking at how we cycle works where humans decide it doesn't go past this point, and we bring it back, right? We take inputs and we keep pushing down the line. We push hardwood, we push things back. You know, we've gone in here and we cut a lot of trees and put a lot of trees to drop those in to build what we need there, right? Yep. And we go in and here, how long can it go? Well, it's the way we plant it that keeps the regenerative cycle. So looking at where we decide how far we want it to move along on that path, right? Is that in alignment with this?
Yeah, that's right. I think for me, like a conscious decision around land management, to me, will be understand this process, looking at where the particular area that you're managing sits in that process at the moment, and looking at what your goals are for that space, how you want to manage that space, and making decisions based upon knowing where that's moving and what you want to achieve from that space. So for instance, our grazing systems, to me, are working with succession. They're understanding that we're wanting to graze the grass before it reaches this point in its cycle, so that we can keep it in this pumping growth phase, and we create a disturbance to renew it back and try and keep this cycle tight here, so that we keep on having grass. If we didn't do that grazing tight enough to do that, we'd start to move towards perhaps this kind of system. We start to lose grass resource, and we have to change the animal management systems we do. Same way in a market garden, to keep this annual action going on here, we need to provide inputs to keep that going. And so by planting tree lines alongside, by utilising animal manure and other areas that are sort of tapped from other systems, we can keep this pumping, which is what gives us a lot of fast food, which gives us a lot of high turnover, high return, high monetary return species as well. So we can utilise, understand the bigger successional system we've got. We can have little spaces of these and use them to feed one another to continue what we're doing. So we tend to find that the areas that we create management systems where we want to manage them less intensively for longer term returns, we can actually allow this process to do more of the work for us. If we're wanting to move things along, we've got food to grow, we've got money to make, we're going to use short cycle plants that need a lot of input, a lot of management, we can do that too as well. And we do less of the on-site ecological processes for that, and maybe we use some of the other resources from other parts of the site and the ecological processes that they're using to feed into that system to boost it up. So I think this is a great framework to understand, and I think it's a foundation to start to make decisions around land management systems, no matter what we're doing, whether we're grazing systems, whether we've got tree systems, whether we've got annual market garden systems. Understand that process, and for me the goal, to me personally, we looked about what is, we talked the first week, what is regenerative agriculture. For me, an understanding of on-site ecological processes and working with them to harness, to drive the process you're in is a key part of regenerative to me. That's a key part of this, that on-site ecological processes, we become more and more using that energy to fuel what we do, rather than off-site external resources, which at this stage of regenerating the lands, what we're all using in our systems. We're all bringing in off-site resources. We're bringing in crushed volcanic rock from off the site in the quarry nearby. We're bringing in chicken manure from other chicken systems off-site. But we're using more and more of our own on-site ecological processes. So the more attuned we are to this land, the more we're actually utilising this process for our benefits. But to boost the system on a degraded site that we're on, we're boosting that from off-site external inputs at the moment. So for me, a key part of regenerative is something about becoming more reliant upon your on-site ecological processes. And natural succession is for me, the template of understanding that.
Like on that tapering off of an old growth forest, what are some potential limiting factors that you see besides allowing space for new growth? I guess for me, one I see is phosphorus can turn into a huge limiting factor in a food forest scenario. In terms of if you're going to take something, it needs to come back, and phosphorus isn't a resource that can be pulled from the air like nitrogen can or something like that. So I think it's interesting in that context of inputs. It's phosphorus system managed by humans with something with the intention to take, you always have to put back.
Yeah, that's right. That is when we're relying upon taking large amounts of produce and the high nutrient produce, the nutrient dense produce from it, we need to cycle back. And I've pondered on this a lot. Like, has anyone thought about how that would happen in nature? What sort of, animals. So like we have things like for instance, we have eels in the south here, in the northern hemisphere is often trout, things that go down, spend part of their life cycle fattening up in the ocean, they come back and they bring that back up. And in the northern hemisphere, bears eat them or eagles eat them, and then they ship that back up. They perch in high spots and they ship back. So there's some inbuilt cycles that nature does, but once we've disturbed those cycles of nature, we need to go, what can we do to replace that process as well? If we start to ask more of nature, we need to go, how do we provide those mechanisms that we've maybe broken through that process? So I think that's really interesting, that one. And I think I look at a lot of animals that come and feed. We talk about edges and the value of edges. A lot of animals that come and feed at the sea, where there's all these nutrients, there's all these minerals, and they come and perch up on a forest somewhere and they shit, and they maybe die up there. And but certainly, fish, water species can actually do lots of things, climb back up the waterways and return that back. They go back to their same breeding grounds every year, and they bring those nutrients back up, and animals predate them. So there needs to be processes to do it, and nature has its way of doing it. And if it doesn't, we ultimately have leaching and demineralisation in those areas if we don't have some sort of process that brings that back.
What would be the process to bring it back instead of adding in that phosphorus?
Yeah, well, for us, what we're currently doing is bringing on high density nutrients from off-site. So we're bringing in like rock dust, we're bringing in seaweed, we're bringing in phosphate deposits from off-site, small high density amounts that we can distribute throughout the land, and then hopefully cycle them well within the land and minimise how much leaching we actually have from that, try and keep our cycles tight, but know that there is still an output to that cycle.
The phosphorus example, an exciting opportunity that I've seen is the way we manage our bones. They're up to 37% phosphorus, and then unlocking it through burning it and being able to feed that back is one really interesting way. But for me, phosphorus is a huge one because there's whole islands out in the Pacific where birds migrate to that are full of huge supply of the whole world's phosphorus. And if it's migrating or from human interaction of taking it, I think it's a really interesting discussion.
I want to steer this talk of like nature's ecological processes into how we can harness that same pattern into how we grow food. And because we have maybe like half an hour left, and we want to go into what resilience.
So resilience, which we've talked about here, I got taught by a local regener, Dave Rawlins, an amazing guy. He talks about resilience as being a function of succession and disturbance. So how we create disturbance within this successional process determines how much resilience we can build. So
should I have these and do up a little
sure.
grid?
Yeah, sure.
So this is a way that...
Oh, you want to move straight onto that?
Do you want to, or you want to...
A little bit more. We can move those. We can start that process. So what I want to just pose is this idea, which I think is a really important thing to explore. In agricultural systems, generally humans or some animal that we manage or some machine that we manage tends to be the disturbance in the system. And I'd almost define farming as being how we choose to manage disturbance within a successional process is the lens I view that. So if we're, like I said before, if we're being, if beef is our product, the way we manage grass, that primary resource of the feed of the animal, or even some of the trees for fodder that might be starting to form in this earlier stage of succession, grasses and trees, the way we manage this stage of succession really determines how successful we are as a cattle farmer. And if we can manage this stage of succession where we can utilise diversity and some of those factors of stratification even potentially, and we can like build our soil biology and work with building more kind of cooperative relationships, we can actually build resilience in our system. And so resilience is going to equal drought proofing, it's going to equal less loss of nutrients off the side, less leaching, less erosion, all that sort of stuff. If we're market gardening, same thing. If we can use deeper rooted plants, if we can integrate perennial plants, if we can use other plants, even if just having like bird perches around, it's like, okay, in comes biological control, in comes droppings of food that's actually come from somewhere else off site. We can start to tighten up in our system. Bringing in animals to integrate in that system too can all be parts of how we can build diversity and resilience in that process. So how we use our disturbance is key. What we've tended to find over time on this land before some of the decisions we've made with moving towards regenerative farming is that over time, what's been happening is regression. We've actually been eating away at resilience. So the constant grazing for up to 100 years or more on some of this land meant erosion, meant loss of nutrients, meant loss of topsoil, and this constant moving back. Every time that succession develops, we move back again. We try and take out these factors and sort of move back again. So the way we create our disturbance is vital to how we create resilience. And I personally think resilience is the key to regenerative farming. So how we utilise that is the foundation. So some human societies and a lot of the colonial societies have tended to focus on this fast-growing food, this really high-return food, and animals that depend upon that fast-growing stuff, because that's often the way to start to build a quick food system, start to build high ecological turnover. But like I said before, Tyson Yunkaporta was saying is that cultures that don't move on get moved on. So it's like, so we can utilise this, but generally we tend to find that the cultures that have had long-term survival and long-term successful evolution have usually utilised periods of time of intensive disturbance within succession and then a period of time for recovery, and generally work within that on whatever time frame it is, and maybe even hundreds of years in this stage of succession. But eventually forest returns, rebuilds soil, replenishes, and then clearing can happen again. So we generally tend to find that intensive disturbances, which is exactly what we're doing with the grazing, same system, intensive disturbances followed by periods of natural succession tend to be what builds resilience. So whereas if we look at the former grazing as an example, having sort of large paddocks, long periods of time on paddocks, we actually have a disturbance which is not intensive but over a long period of duration. We tend to find on most land that means regression, not succession. Whereas intensive disturbance for a short period of time and a long period for succession to develop tends to build that regeneration. So we can look at it on different levels. It doesn't need to be long-term forest levels. But many of the tropical forest systems, which I'm going to refer to as till a couple of minutes, I'm not far away, is...
You put an hour for it, so I'm just going to help you. Leave you a few minutes to go through it.
How many minutes have we got left?
Like 25.
No. Okay, so... Alright, so the tool I'm going to share with you guys, which we use for our agroforestry systems here, is looking at this sort of simplified stratification idea of the forest system. Looking at this multi-strata, simplifying it to 4 main strata. And we see our process often starting from here, or starting from some stage of succession, moving with our diversity, and along with diversity is also productivity. That's increasing, overall ecosystem productivity increasing over time. And we're working with a process whereby we can use disturbance within that to build this productivity, build that resilience, and to use this particular forest structure as our patterning. A lot of the humid tropical, subtropical ecologists have worked with this process whereby productivity and diversity is at its sort of maximum incline, and we tend to find in a lot of the humid tropical and subtropical forest systems that this might be somewhere in 10 to 20 years within succession that we find this build-up of soil carbon, this build-up of diversity, this build-up of nutrient cycling and stratification, is at a point where it's on a maximum incline before it's going towards a slower incline, even a decline over time. We tend to find that a lot of agroforestry systems work within a period of 10 to 20 years of succession, make a large disturbance, come back and work that process again over time. And within that 10 to 20 year period, we can actually be growing potentially a lot of valuable timber for food, for firewood, for fuel, and lots of crop plants. We've got early stage annual crop plants. We've got things like bananas, tamarillos, pawpaws. We've got longer term food trees and timber trees. And we get to a point where a limiting factor starts to become the amount of light coming towards the ground. And so therefore the amount that humans can harvest in this system starts to get more challenging beyond this point, because humans are good at harvesting this area, they're not good at harvesting way up there. So a lot of human systems that use this succession in tropical forest systems tend to have that pattern. They use succession for 10 or 20 years, and each time they come back to here, if they've managed this well, they've actually built more resilience in the system. They haven't degraded the system. If they start doing disturbance too early without external inputs, they can actually degrade the system. And a lot of areas this is happening because of economic pressures and land degradation. But this is the kind of system we're looking at in this tool I want to share with you. So in this particular period, the forest stratification we look at has sort of been simplified to being potluck with pens. Okay, so emergence here, filling about 20% of that band, so it's not full of emergence. So emergence of 20%. Our high strata plants here filling about 40% of that band, which still leaves plenty of light coming through for our mid strata to fill 60%, so mid 60%, and that still allows enough light in that early stage of succession to have this low strata about 80%. So the most easy human management areas of this are going to be these lower strata here. This stuff ends up being maybe some fruits and nuts that fall down, maybe it's timber trees in the long run, but a lot of our food turnover is actually going to be in this lower strata system here, which is a big reason why a lot of our food systems are built down this area. Humans can manage that well. They can control resources well. They can look after that area much better than once things start to get 30, 40 metres high. So this foundation of this structure is the fundamental understanding behind this tool I'm going to share with you guys, which a lot of you have seen before and used. Any questions on that before I move on? We're choosing a point in time in succession, and in these humid tropical and subtropical forests, we're observing what that forest type structure looks like in that period of peak productivity. Yeah? And we're using that as a prototype to build our structure. So there's a table we can use for this, which has been evolved through a lot of Brazilian agroforesters, which have brought this simple tool has brought really great insight and great opportunities to actually communicate with one another the complexities of creating these sorts of systems. And if we look at drawing out, let's use that one.
This is what we call the life cycle strata analysis.
Yeah.
And so rather than just looking at succession or like time, and rather than just looking at the layers, it's a way to bring both the layers and time together in order to build a system.
I usually have this one prepared earlier on the back of the board, so bear with me on this one.
There's a few other things that I brought over.
Yeah, okay. What was that one? I'm always, that's all right, pop up. There we go.
Yeah, I think the girls are using these episodes. I think they're the good ones. The blue.
Look at that. Alright. So, okay, cool. I'll just get this on the black now, I'll change colour. So, life cycle, we'll talk about. Strata, we talked about emergent at 20% density. high strata at 40% density, mid strata at 60%, low strata at 80%. So, and the life cycles over time, some of the quickest stuff you guys are growing in the market garden, what's some of the turnover? Some really fast stuff. 6 weeks, yep. So like 0 to 6 weeks could be a good first life cycle. Then maybe like 6 to 12 weeks. Then maybe we've got 3 to 5 months, 5 to 12 months, 1 to 3 years, 3 to 6 years, 6 to 12, 12 to 20, 20 to 40, 40 plus, let's say. So what we can do, we can utilise our understanding of this forest composition and look at how we can create a succession using plants that are, providing ecological function, but are primarily for human resource use, food, fuel, fibre, medicine, all that sort of stuff. So we talked before, what are some of our fast growing stuff? Coriander. Okay, so coriander might fit in here at this sort of high strata. It tends to grow as a little bunch and coming up that way, yeah? What's something that might grow fast like that but maybe tuck a little bit under coriander? Yeah, lettuce might be a little bit later in the system. We might be able to get some early lettuce out that time, but maybe it's a bit more in that 6 to 12 weeks. But we could make, what's that, sorry?
Radish?
Yeah, radish or rocket maybe. Could be coming in here. Not growing quite as much vertically, but spreading quite wide. And that could still have space up top, maybe to have something like amaranth. Really quickly, bulk up as it's tall emergent coming through. We'll take the tops out of that. We're in this period of transitioning from a lot of those warm season crops to cooler season crops. But if we look at maybe some of the crops we've got in the ground that are at maturity, so you guys kind of understand the process a bit more. Yeah.
I might have missed it. So is this in the context of the market garden?
This is in the context, it could be in the context of any management system.
Yeah.
However, the context here we're looking at is within that natural succession we talked about here. Let's say we've made a disturbance in that 10 to 20 year period, or we're just starting from our degraded grassland and our disturbance is coming and ploughing along, adding some chicken manure, adding some rock dust, doing what we're doing here to start to build the system. And then this is day one after disturbance.
Yeah.
But what we can do is we can plant these shorter cycle crops and turn them over, which we do in a lot of the high turnover parts of the market garden. But we could have crops that stay longer in the system too. And we could have some crops like bananas and pawpaws that are longer in the system. And what we could do, which is what we're doing in some of the areas here, is we could actually design an ecosystem whereby we've still got crops in here. There might be pecan nut trees, there might be soursop trees, there might be timber trees, there might be rainforest understory plants we can utilise for medicine. But we can actually plant the whole lot day one together as a whole ecological community, and we just remove parts from the system as we go and leave the later parts of the life cycle to evolve.
And in this grid, is it like, why have you got radish and rocket as is that medium height?
Yeah, so for this period of time, even if we planted, let's say we planted a,
in that time.
let's say we planted like a pecan tree, right?
Yeah, someone was talking about cosmos being an emergent, and like, yes, so you were talking about cosmos being an emergent, and like, it is in that very first layer of that tree row before the bananas come up and the casuarinas grow.
Yeah.
So in each period of time, you have the emergence, the high, medium, and low. It's not like I was kind of understanding it's like in the first period of time you have the emergence, and then you might have a next.
The idea is at any point in time we're trying to recreate that structure of emergence 20%, high 40%, and at different life cycles. These guys come in that early stage of succession. They've done their job. They move on. The next stage of succession will have a similar structure. So the way we plant, the density we plant, and the way we manage that system to try and keep this structure is one of the ways that we can maximise that diversity and resilience in the system, and therefore maximise that returns from the system.
And that's the same structure as in like an old growth forest?
Not an old growth forest, a young forest at its peak point of development.
Peak point.
Yeah, that's right.
You can do that at any stage.
that's the philosophy behind it, the theory behind it, and there's practically how we work with it at different times of the year may vary, but this is a really good template to start this process, to start to learn from and play with. So one of the other crops that we could have in this system, have we still got any corn standing down there, or are they corn in the system? So corn tends to come in here, be harvested 3 to 4 month period usually, and it's finished. So we could easily, as our annuals here, have something like Amaranth and Cosmos, corn, and is there some sort of emergent plant we could have that could have been growing under the corn? Once we cut the corn out, it might start to take over that
Like
crop.
sunflowers or something.
Yeah, sunflowers are probably similar to corn. I don't know if they last a lot longer than corn, maybe a little bit longer. They're sort of a similar life cycle. Yeah. But let's say we're developing a food forest, we're going beyond. So cassava could be one of the ones that's coming in this sort of medium to high strata. Some of the cassava being harvested at the moment has been there for nearly 18 months. Usually will be harvested somewhere in that 9 to 18 month period. And coming up in gaps in cassava, we could be having like papayas up here as well, poking through some gaps as well. What's that? So sweet potato could be this great low strata. So in some of the systems we're planting here, we generally see sweet potato being in the ground, if it's in the peak growth period, 3 to 5 months over the hot season, and then removed from the system. Yeah. So the reason I put this in this box here is that's sort of the period where the sweet potato holds its fullness of form and it's coming to the point of fruition to be removed from the system. And ideally, if we want to keep this system pumping, we try and remove each component from the system while it's at its peak productive point to allow space for the next opportunity to come. So there's no reason why we couldn't leave sweet potato there for quite a few years, but its peak production of use of space and time is going to be harvested in that period. And then we'll remove it and we'll allow space for another low strata.
I got an interesting story about this from Sharon Doherty.
Yeah.
Did some research for Cadbury, I think it was. I can't remember where, but they did a whole bunch of controls, and that percentage was the one that worked out the best for growing the cacao.
Okay.
I thought it was really good.
So which percentage for cacao?
The strata, so 60% cacao to 40% high and 20% emergent was the most productive. That they came up with.
Awesome. So cacao in its native system would be in the ground 5 to 10 years from the seedling or whatever, and it's going to be most productive in that 10 to 20 year period under those layers. So the way cacao would often be grown in tropical systems, and maybe in a few sun traps here we might start sneaking it in and playing with it. We'll be sitting somewhere like here. Its peak production is going to be how many A's in cacao? Stacks. We'll be somewhere coming up to here, peak production, and if we can continue to manage this emergent strata to not dominate too much, we could keep it in peak production for a long time, maybe longer than it would in nature if we can keep on preventing this emergent and high strata from becoming too dominant. So that's why that 10 to 20 year period is there. If we don't continue to manage this emergent to high strata, we get very little sunlight coming down to these lower strata, which is going to affect the productivity of these crops. Yeah. Any thoughts of other crops and thinking about where might we play with that if we're going to incorporate them in this system?
I guess
What's that?
like roots, like ginger and stuff.
Yeah, so ginger and turmeric I generally work with. You're going to harvest them usually about 8 months or so from planting. Would be ideal, 8 to 12 months from when they plant. It's usually when I pull them up out of the ground before they start popping again. And I consider them as low to mid strata here, ginger and turmeric.
Taro in that same.
Yeah, taro more in the upper part of that scenario, and potentially we could have in the ground a little bit longer, but yeah, generally the taro is sitting above that ginger and turmeric in that sort of medium strata. These are the medium to low. So again, like most things, once you draw a box around something, you start to limit your understanding. This is great training wheels, but the reality is things don't fit in boxes and things fit between gaps of boxes and things like that. Yeah. So.
I have a question, like, I see like tomatoes and beans often in farms, they put like fence or something so it grows, so could you also use some kind of structure to put it on the height you want to be, or would that be?
Oh, sure. Yeah, so that's right. So and things that are vines or climbing plants often tend to have the ability to move between those strata. And you can see what their intention is. You can see where they want to be, but it's about how they can get there. So most of our vines sort of want to end up being somewhere in this upper strata, and if we can provide them support to get there quicker and to not have to clamber over other plants to do it, that's a really sensible management decision. So we probably tend to find a lot of our like tomatoes and climbing beans tend to fit into this sort of area here. And if we provide them a trellis, we can neaten and tighten up management. But we could just as easily, like some of the plantings I've done of tomatoes in the last couple of years with my wacky compatriot Evan and his cool and kooky plantings. He'll plant.
What a title!
He'll plant. It's a great introduction. It's a fair introduction to Evan. We'll plant like corn, and in amongst, like right at the base of the corn, we'll have things like chilies. Chilies are going to be more like here, coming on after the corn's finished. The chilies start to come on. But in amongst the corn, or in between a couple of bits of corn, will be a tomato plant that's being held up by the corn. We can kind of weave it back in around a corn leaf and can kind of carry up through that corn as well. So yeah, we could also do a trellis to make it really simple and clear, easy, but we can also play around with how they interact more tightly if we want to as well. Yeah. What about some of these crops up here? And the important part about succession is understanding that if we compose this process well and we manage it well, we don't have to sort of do that process, especially if we put in this disturbance, if we come in and go, bam, with the kind of high density inputs we're putting in, seaweed, we're putting in rock dust, we're putting in epic compost that's inoculated with all that biology, it's just going to speed that process along. It's just like, we don't have to wait 5-10 years for this process to happen. If we come along and we deep rip and we're getting plants to keep on sending their roots down and opening even more, and we provide everything we can in that topsoil, we can actually accelerate that process for our own productive gain. So if we're going to do that, we don't necessarily have to wait, 10 to 12 years in our regenerative process for like a few pioneer plants to move in, eventually a bird to come and shit out a cacao seed or something like that, or eventually to wash from downstream a pecan nut to land in the right place and come up. We can go, you know what? I want pecans here in the long run, or I want cacao here in the long run. I'm actually going to start day one. And because my cacao likes to have a bit of shelter, I'm going to tuck it in right underneath the cosmos and corn, nice and tight together, so it gets shelter from day one. And once the corn's gone, fortunately it's going to have shelter from cassava and papaya. And then eventually, if we want to get some more sun to it and we remove those, it's got shelter from the pecan or the soursop tree or whatever else it is that's giving it shelter. So if we're going to think about other species we could plant from day one that are going to give us returns down the track while we're growing our annual veggies, what are some of those that we might think about doing here?
Maybe some like mid-strata, like legume trees, like the Mexican fern.
The Mexican fern tree, I see, it kind of wants to be an emergent. It wants to push up. So it might start in amongst other trees and be happy to do that, but it wants to be an emergent. That's really where it goes. So the Mexican fern tree is kind of, will be powering up above the fire by this stage for sure, if it hasn't already earlier. And it wants to stay as an emergent generally. It's pretty hard to fight that to be staying down there. So whilst you might see it come up slowly underneath that corn, I don't have it written on here Mexican fern tree because I placed it in this management tool here when it comes into its full form, which will be, somewhere in this period here where it really starts to rise up above the cassava. I guess the cassava and the papaya are things that might get up a bit quicker, but then once they're established, the fern tree will come push through above them.
I think to use this, a model that everyone's been working on in the tree rows in the garden, we put in bananas on the first day, and then we also put in casuarinas, which kind of fit in that.
In this as well too.
Yeah.
So the casuarinas are going to be the ones after things like, say, a banana, we generally put in, starts production usually within about 18 months. You guys are starting to get your bunches of bananas 18 months time. They're doing their job. So bananas usually hold a fairly strong part of that system from about 18 months to the first 5 years. They tend to dominate that sort of mid to high strata. And coming amongst it will be emergence, which the way you guys have designed the tree rows there is going to be the casuarina starting to pop up above it. And that casuarina is going to start to provide perches for birds. It's going to start to provide some wind protection. going to start to provide a bit of microclimate creation. It's going to start to send its roots down, break up that soil, sop up some of the moisture you get in the wet season, and open up that soil for more air.
So the emergence, like, they are the things that sort of emerge after the initial phases of like...
No, not necessarily. Emergent is more defined as a plant that wants full sun, that just wants to be up there taking it all. And so usually its process is it just goes up.
Yeah.
No branching. You take the nip off, it just sends another one straight up. It doesn't branch into 3 or 4. It just keeps going up. So palm trees, coconuts, a lot of those pine trees that just only go one direction, that's a classic emergent structure. Yeah, moringa's another one. Papaya does it, obviously. Papaya just wants to go one way. You know?
Is jackfruit emergent or is it one below?
Yeah, jackfruit's different people classify it differently. I see it in this high to emergent, a bit like the pecan. So it's coming in a similar time here. It's interesting because we can, through our management systems, influence a little bit where the tree sits. It might want to be somewhere where we don't quite want to let it go. So I don't really want to let a jackfruit fully become an emergent because it starts to get really hard to manage. So with a bit of pruning lower down, I could bring it back to being a high strider and we could still have the odd casuarina at 20% up above it. I think it'll work fine. But different people in different systems manage it either as a high to emergent, somewhere in that zone.
Yeah. In Asia, we put rambutan above it, so the rambutan is emergent jackfruit system.
The rambutan sits above the jackfruit. Yeah, cool. Okay, cool. So rambutan is generally something that's a bit more tropical than people grow here, so that might be your emergent up there, hey? Rambutan, the jackfruit's just sitting below. Cool.
I feel like something that sort of helps me think about where things want to sit, and is something that came from Robin, so if it doesn't, and you wrote it, but if it doesn't sit with how you think of it, then but it's like looking at where things flower and fruit tells you whereabouts in the system they want to sit. And so if you think about a mango that flowers on the edges and then its fruits drop down on the outside, it wants to be that canopy. It wants to be up with the sun, whereas something like a papaya is happy, or a Davidson plum, like they're kind of happy to sit, even that they fruit on the stem. And so, and polycarpa as well, like they're happy to sit under the canopy. That's
polycarpa's a classic for that, yeah. It's fruit's right on the inside, it's not seeking the sun, it's happy to sit underneath there. Yeah, that's another good way to look at those things too. The cow's the same, fruit's on the inside in there, it's not seeking sun for it, it's happy to be in that humid, darker, cooler part of the system. So, and like I said, disturbance is still a key part of this too. So whilst this system could be ongoing, at any given time here, we might start to look at how we design, how we manage that system, and ask ourselves how we could create disturbance to make this work better. So what are some of the ways you guys are doing that in your tree systems at the moment? Creating disturbances? Pruning. Yeah, absolutely. So we can get to a point through either plant density or the density of the crown of an individual plant where we start to sacrifice the amount of light coming into the productive parts of that plant, and pruning is a great way to work with that. And pruning is also a way that we can have stratification here without having all that stuff way beyond where we can get it. So we can actually work with our stratification, but through the tool of pruning, plant spacing, etc., we can kind of bring the scale of that down where humans can manage it better, so that we're not fighting the birds and the bats as much as we would be if we just let that whole system go. So the way we originally plant with density and the way we manage it is going to be key to how much we get returns from this. We know working with this process is going to be valuable for the ecology because that's the blueprint in nature that we're working with. But it's about how much we can get from that system to keep feeding ourselves as managers, to keep perpetuating and propagating and maintaining that system. That's key, and that's where our management techniques, how we use that experience is key. We tend to find in these systems that are going beyond this period here too, we tend to find that valuable parts of the system are no longer just fast return food, but can actually start to become timber for building, for firewood, for various other purposes. Even just for feeding the soil, for feeding fungi. So a classic one that evolves is our beautiful low strata down the track here. We might be starting to get less light to grow things like sweet potato. We can still have it every now and then we do a little pruning. We can go, okay, a few years down the track we heavily prune it. Let's bring in some ginger and turmeric. And maybe if we make a big enough pruning, we could even say, And you know what? Let's plant some corn above it. Let's make a disturbance in the system somewhere. Boom. Let's do a clearing. We've got some diseased fruit trees. We want to open them right up. We want to cut them back to stumps. We create a little forest clearing. In that forest clearing, we can go, let's put all the material back on the ground, woody material, feed the ground. Let's inoculate some fungi in that system. To look after that fungi in that clearing, let's plant some corn around it. Let's plant some climbing beans up the corn. Let's put another crop of sweet potato in. And in the gaps, we'll put some ginger and turmeric. And through that forest clearing, our limiting factor previously being light, we flood light into the system. We warm the soil, we bring light, and we can actually look at again these earlier life cycle plantings and have a little moment in time where we can get some higher returns from plants that humans can manage to get food out of it. So it's not that because we're starting this focus, it's not that like we're leaving this behind. Like we said before, if we just let this succession develop, it's like, oh damn, I miss sweet corn. I really like my sweet corn and don't have enough light for sweet potatoes either, or can't grow my lettuces anymore. So we can make clearings within it. We can strategically harvest. We can strategically prune trees, harvest timber from our casuarinas or even our pecan cuts, jackfruit. A lot of our long-term fruit and nut trees are actually amazing timber trees too, really valuable timber trees. So we can look at different value of resources we can get along time and use our disturbance to extract those resources, use the opportunity to bring those resources into a decomposer cycle that could give us more food and monetary returns and feed the cycle to get a whole bunch of other food plants going, and then that succession continues on alongside that clearing. And we brought more diversity into it. Remember we talked about over time we can get our diversity drop off. If we don't make those disturbances in the system, we can lose diversity in the whole system, which is going to be our early succession plants, which right now is a lot of the stuff that's turning over money for this space, and it's high turnover food and doing a quick response to the work we're doing. So so disturbance can be our way of managing that system to build productivity and diversity, and if we do that well, we're building resilience as we go as well. Time up?
No, we have 10 minutes.
10 minutes still.
Yeah, I just checked with the kitchen.
I've been ranting for ages. You even gave me a brief propose for ranting while you let these guys do group work, and I've still got 10 minutes of ranting left to do.
So
Maybe I
yeah,
can
if
listen to
anyone
you
has
guys.
any questions.
Yeah.
I wanted to ask about like animals in this system and like what your thoughts are on integrating animals like between rows or just throughout it at any stage.
I see, as we looked at, well, we didn't go into a lot of detail in that early succession, but animals are key drivers of this system, and whether we're introducing animals or not, they're going to get their way in there. That's been my experience. So it's like we either choose the animals we want and manage them the way we want, or else we get what comes. Animals that classically come into these systems, whether we like it or not over time, will be things like rats and scrub turkeys. If we don't clean up our crop waste, if we don't kind of keep things tight and clear and open. So if we actually consciously bring animals in and manage them, there's lots of ways we can do that. So part of the structure we can do with this is go the way Ivan and the crew design the market gardens. You go, okay, we've got defined tree lines, but then we've got annual lines that we're going to keep in higher turnover. Some of those annual lines could be areas where let's bring the chicken tractor in there, or down the track it might be like, okay, we're now in Pecan City, we're harvesting a bunch of pecans, but a lot of the early ones and the late ones do drop and get a bit of disease, so we could let pigs in and eat them. You know what I mean? There's other ways that we can integrate at different stages of succession, integrate animals. And down the track, part of our goal for the system could actually be a system that big animals like cattle we integrate into. Once we've got big trees, and with cattle you tend to have, like if you've got 4 or 5 trees in a paddock, they get too much rubbing, too much compaction, and they die. They go downhill in a cattle system. Whereas once you've got 100, 200 stems of trees in a paddock, or 500 in a big paddock, the cows don't put any particular pressure on one tree enough to have a really negative effect on them, particularly if they're being rotated as we are and they're not fixed there all the time, camping, compacting, rubbing. Big animals can be brought into the system as it evolves too. This is not like, this is no sudden brainchild being on. This is what people of the subtropics and tropics have been doing forever, as long as human civilizations have been doing their thing. And before, you go into parts of the Pacific and Southeast Asia areas that I know well from these sorts of systems, you always see big animals underneath big old trees. You've got huge jackfruit trees, you've got huge breadfruit trees, you've got all these giant trees for food and timber and that. Cattle are in there. There's enough stems of trees. Cattle are a part of that system. And they're cycling. They're actually keeping diversity in the system. So they're munching down some of the pioneer trees and shrubs that might actually be suppressing light for the grasses. So they're keeping little grassy clearings within that space as well. And by eating, by dropping the manure and the biological inoculant within that, they're cycling the system. They're keeping it fed. And then someone's doing the pruning. Actually, someone's doing the pruning themselves as well. Any other thoughts or questions people want to talk about in relation to this talk?
I just had a thought that might be interesting to people. African game reserves or safaris got elephants that knock over trees and kind of prune so that other animals can get those bits that they couldn't reach at the top, nibble on all the different plants, and how it's very different kind of ecosystem. But yeah, in the middle of the day, they're all hiding under the trees, or at full moon, they're hiding in amongst the shadows so that they're not eaten by the prey. I don't know, and that just came to my brain.
Yeah, that's right. I mean,
a very different way of thinking about.
Yeah, Africa's one of those few continents left where there's still some quite large populations of those big herbivores and big animals, which in a lot of other parts of the country have been hunted out or lost through climate change and other different systems. So Africa is a really interesting example to look at how big animals relate in evolving long-term systems. Yeah. So it's a great template to learn from. Yeah.
I think what's really, I was about animals still and thinking about growing fodder crops and starting to transition those really healthy pastures, or just getting trees in there, whether they're fodder crops for the animals or whether they're long-term fruit trees, to know that you couldn't, I think it's so beautiful to think you couldn't just go from a set stocked, for 100 years cattle pasture and start putting those trees in. We need those cows in order to be kick-starting that biology and doing all the cell grazing in order to grow that soil and to put those roots down in order for those trees to then come, and it's a really nice cycle, I think, in my head to go, we can grow food either for them or for us and have that integrated system, but we also still need that grass in the beginning to be building that soil and moving along that ecological succession.
Cool. I might just point out, because a few people that were working with me this morning, we were just doing a little process where we planted cassava 18 months ago. Our intention was to harvest it somewhere between 9 and 18 months, and it's stayed in the ground, or some of it's already come out from 9 months' time. We started moving some, but now that we're actually moving larger quantities and selling a bit of it, it's been really great because this is actually going to here, and this, the longer this holds ground without management, the more it actually suppresses this opportunity. If we don't actually keep things cycling and tight and remove things as we plan or prune things as we plan, we can start to get this emergent high strata dominance, not much light getting down. It's so we looked under there, our ginger and turmeric's been held back all this summer by the cassava that wasn't quite harvested. The bits that got harvested, that got a bit more of a head start. So what we actually did today was, in one of the systems, we made a disturbance after 18 months. We open up some light. We'll get a ginger and turmeric harvest a bit down the track. They're still growing and happening up. The taro and the ginger and turmeric have been a bit held back by this. I would love to have gotten that a bit earlier if we had the market or the demand for it. It's held back these to not be as full an expression as they might otherwise have got to. And what we've done, by making that big open exposure now, by digging up heaps of cassava plants at one time, we've created a big disturbance. We've now been able to come back and enter our full sun crops again. So we planted silver beets. We even planted some eggplants and some full sun stuff that would never have had the opportunity unless we made that clearing and disturbance. We sort of got a second chance of growing annuals there. If we didn't do that, if we left that in the ground 3 years or ongoing, which it could have stayed in the ground, by then papayas, casuarinas, all other stuff would have shaded the ground so much we'd have had to have made a really huge disturbance to get that opportunity again. So the way we design and manage systems determines a lot on how quickly we can cycle that nutrients and what we can get out of it. And so, so my suggestion is not that we use this tool everywhere we go and we're always just about creating forest everywhere, but we use this tool as an understanding of how we manage things. So we may choose to manage some areas of forest, like this particular garden, the nursery garden there, we didn't plant beyond this in mind because we left that space very open for the opportunity of what might develop around a DA and possibility of other buildings, and understand that site is a key site in the inner hub of this area close to the hive. So we actually didn't plant trees that would last longer than that because we saw that there might be a need to come in and transform that site, put in paths, landscape in different ways to support what might have evolved. So we chose not to do that. So in our cycle, we chose banana and cassava, papaya, a bunch of plants there, and we could just as easily, in areas, we might decide that what we want is not more woody plants, because we've got woody plants everywhere, we've got firewood, we've got these other things. We could choose to go up as far as bananas, or say 5 years into the system, then send in like ducks, pigs, whatever, smash all that biomass down, turn that over, and start again. So we can choose by the area we're using, what our management goals are, what the products are we want to work with. We can choose to work within a stage of succession and understand what disturbance we're going to use to be able to come back and start that cycle again. So like in some areas we might be just like, so if in a market garden all we were growing was just like coriander, rocket radish, that's going to be real high turnover. It's like boom, boom, boom. And the question is, you'd always ask as a market garden, is there enough returns from just growing a 6-week-old crop, to validate turning the soil again and doing all that sort of stuff. So we tend to find that market garden, some of these crops might be planted amongst some longer term crops like lettuce or brassicas that might be being harvested, 5 months time, might be harvesting broccoli or cauliflower and things like that. So you'll see different ways even in that short term annual turnover stuff. You'll see even in some of the market garden that guys still use some of those stages of succession to be those gap fillers that do the quick first pump, remove them from the system until the long-term guys hold that soil, and at a given time, disturbance comes into that process and we start the cycle again. So we can look at whatever scale we're looking at, whatever kind of scale of turnover we're looking at, understand this process can only kind of help us to see how we can use disturbance as a tool to build resilience. That's sort of what this is about to me. Yeah. Any other thoughts or comments on that tool? Or ecological succession as a whole that we discussed today?
I have one quick clarifying question. I'm confused with the percentages.
Yeah, okay. So this is why I love to have a double door. I can just go bam, and there it is again. But I have to draw it up. So we're looking at that period of, this is built, again, it's really important to understand this context. Disregard, this doesn't belong to this bigger map. This is a little window into a different story. So what that reflects is emergent trees, not covering 100% of that band of that whole, but just 20%. And high strata being planted at the kind of spacing where they're covering 40%, but still letting that light in for 60 and 80%. That's what that's built on. So again, the important context, the important context of this is built on the idea of the humid subtropical and tropical rainforest, which is fertile, humid, seasonally high rainfall environment, which has the ability to build a lot of biomass, build a lot of carbon quite quickly, cycle that carbon quite quickly in hot, humid conditions as well. So that's what that structure is built on. And I by no means am suggesting that we go to a temperate environment or an arid environment and try to replicate that same structure. That's built on understanding of ecological dynamics of rainforests, of humid rainforests. So you might look at it differently in different areas. Yeah.
Do you know if there's much research into temperate climates and the percentages and stuff like that yet?
Yeah, look, there's heaps of research out there, like from ecological work, that look at, if you look at ecological forest dynamics and stuff, you'll find more about that. And again, this is really that's what's the word, stereotyped, or it's very, well, not even ideal. It's kind of stylized. It's sort of it's a template to work from. In some ways, it's choosing an ideal, stage of forest development. But there's so many. We talked about limiting factors last week. We talked about it again this week. Limiting factors might be soil fertility. They might be reliability of water access. So sometimes we tend to find with more limiting factors, we have more space between those things and less tight stratification. That's what we tend to see. You go further west and you keep on seeing that forest opening out to an open forest where we might not even have emergent species. We might have high strata at 40 to 60% or something like that. We might have a medium strata at whatever percentage, and low strata. And then as we move further in, we just end up having some shrubs and grasses, and we move in further and we've just got grasses, and a few herbs in amongst that. So different ecosystems will have their different structures, and that's about understanding a dynamic within succession, which is not necessarily as easy to find out, depending on how much study's been done on your ecology. But you need to start then looking, if you choose a geographical area, start looking at similar bioregions, similar climates in other parts of the world, and looking at the research people are doing there. So I always throw in the ring people who are looking at this and think of temperate climates. I always say, check out the work of Mark Shepard in the States, who's looking at this sort of idea of an oak woodland with lots of sort of grassy, shrubby areas within. That's the template he's studied and looked at in his area. And he's sort of gone, what are some of the species? He sees the oak as that dominant canopy. He's sort of gone, what are some of those mid-strata species? And the plant families he sees is things like the apple family, the plum family. In this lower strata, he sees those berries in that mix. So he's sort of replicating his forest regeneration system with a lot more space. He's using the same plant families but using cultivars where you can get more food, higher financial returns. And because of that more open space, he's got heaps more room earlier on for like grass grazing herbivores and things like that as well. And down the track, pigs underneath eating nuts and fallen fruit and stuff like that. So he's able to integrate that stuff in bigger bands within systems much earlier than you might in a rainforest system, where the animals might be struggling to get that low accessible feed until you make a clearing again. So he's sort of got a lot more strongly animal dominant system, grazing animal system, than some of the tropical forest systems might, because of that structure he's got.
Wouldn't the animals hurt the berries?
So he will use wide bands as well. So this is where generally designating perennial or tree rows to annual rows or pasture rows really helps, at least to begin with, until those trees are up and going. And again, using things like electric fencing, using those tools to move animals in time and space. So disturbance is about time and space as well. It's intensity, the intensity of that disturbance, the duration of that disturbance is the space, is the time, and then the amount of space we use. So electric fence and solar panels are great flexible tool for grazing. You move them in where you want to move them to. It might be like, okay, harvest is finished in that plot, let's do some pruning, let's open up some space for pasture regrowth, let's let animals in to come and feed underneath on that crop waste and that bit of light that sparks a bit more grass growth. So that's the kind of tools that we can use. So, I mean, really, the electric fencing and solar panels has been an absolute revolution in being able to integrate animals into systems in a new way. I mean, the big reason why we had all those fixed grazing systems is like, how much fencing can you do? And, when you put a fence there, it's pretty solid. You don't want to move it and have to adjust your system. So those tools give us great flexibility to work with how we manage that disturbance in the system.
I'm going to say we can continue this conversation maybe over lunch, but the kitchen has made an incredible challenge. We just don't want it to get cold, so I feel like we should wrap it up. And I want to thank everyone. I know it's been a really long time that you had to sit in the same spot. Thank you, Anya, and thank you, Owen, for drawing all the pictures. Thank you. Can we write what, like March?
March, yeah.